Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at our malloc_01 and take a closer look at the address of individual elements in our array. This video assumes that you have watched the earlier version of malloc_01 as well as some of the other videos in our pointers demo. So to begin with, what we'd like to do is we'd like to take a look at a problem that we mentioned in the first video, and that was the use of this temporary variable value that is simply used to collect the information utilizing our scanf. And so if you recall, we basically collect an integer and we store it at the address of our value variable, only to turn around and insert that value into our array. I mentioned in the earlier video that this could be done in a single step. So let's see how it can be done. So we'll go ahead and comment out both of these lines. And what we'll do is we'll replace this with a scanf that once again utilizes the %d. But instead of the address of the value, we are going to use the address of the array, and specifically the address of a specific location in the array referenced by the index. So in this case, what we are doing is we are directly accessing a specific location in our array. Now, how is that possible? Well, if you recall from an earlier video that every location in the array, or every element in the array, has its own address. And to further highlight that, let's take a look at our int display int array. So our function that just simply displays our array. And what I would like to do is, in addition to printing out the value at a specific index in our array, I would also like to print out the address of that value. And to do so, I'm simply going to add another printf statement, and I'm going to use the %p placeholder followed by a space. And then to just really help it stand out in the console, I'm going to surround it with parentheses. And then what we'll do here is we will populate that with the address of the array, square brackets index. In other words, it's the address of a specific location in the array, and that location, of course, is controlled by the index. Now, we'd like to do the same thing with the last element in the array, because remember, our for loop stops one element short. And so to do that, I'm simply going to remove my new line, and I'm going to go ahead once again using a set of parentheses just to emphasize the address. I'm going to have the %p followed by the new line, and then the address of the array square brackets index. In other words, the address of the element at that location. And then a little minor detail is just to add a space after that last %d. At this point, we should be ready to go ahead and build it. And we can now test our newly refined malloc_01. And in this case, what we're going to do is we're going to run our pointers demo with our malloc_01 switch. This time around, though, we'll pick a few more values. In this case, for an initial number of values here, I'd like to actually have 10, just so that we can really get an appreciation of what's going on here. And you'll notice, once again, as in the earlier video, I have the original address that is stored in the array variable, and then the address of the array variable itself. Remember that those are two separate things. And we print this out both before and after using malloc. So in the second set here, this is the address of that newly acquired chunk of memory that was returned by malloc. Now, if you'll notice here, the values for my 10 elements in my array are in fact still junk. We have not yet initialized them. As a matter of fact, just to prove this point, or just a reminder, I'm going to go ahead and enter in an integer value here, 123, and you notice that my 0th element now is 123. But also notice that in parentheses is the memory address associated with each one of the values in the array. So you'll see here that we have our B0 is the address of the 0th element, which also corresponds to the address in the array variable. In other words, that's the value that's stored in the array variable. It essentially is the pointer to the first element in the array, or the array itself. So remember that the array functions as a pointer, the array variable functions as a pointer to the list, if you would, of integers. And you'll notice here that these memory locations are sequential. So it's B0, B4, B8, all the way up to the D4. And so we can continue to assign values here. We're going to just put in 231 here, and you could continue on, and you'll see that I'm slowly updating this array element by element. And once again, you can see the addresses associated with each element in that array. And to help understand this just a little bit better, we can take a quick look here. So you'll see here that you can think of your array as a series of blocks in memory, which each one of these blocks holding an individual integer. And as you saw in the earlier video, malloc allocates that memory, if it's available, on the heap, and it returns a pointer to a block of memory that you must then cast to an integer pointer. Now, what does that mean? Well, if you notice, just like what you saw in the console, you saw a sequence of memory addresses. And so you can think of these as individual blocks. And then what you can think of is the array variable simply stores the value of the address of that first block of memory. And so we have our array variable that is a pointer to an integer. And if you'll notice here, at least in this example where I've sort of summarized this, that the value stored was A10CB0. And essentially what that was is that was the address of the first block in our set of integers. And there are 10 integers that we were intending and storing in the array. And I've simply just truncated the address here just to make the slide a little bit clear. I'm only focusing on these last two. And you can once again notice that these are just in increments of 4. Where do we get the 4 from? Well, that's because the integer then is going to be 4 length 4. Okay. And then continuing on with this, then you'll notice that we have the address of our variable itself is FEC0. That is the address of this block of memory that stores the array variable. Okay, and so this is the location of this block of memory, and essentially it stores a value that points to another block of memory. And you'll notice here that I do have a slight typo that I need to fix here. I have it as 2 bytes per integer. It depends on what system you are and what data type you're using here. But in this case, it should be 40 bytes for this particular system. It just depends on then what data type you're using. So for whatever the data type will be, will determine then the number of bytes in memory. So this is just an example here of how you would go about doing it. All right, so once again, let's go back to our code, and you'll see now we've got that sequence of blocks in memory. And so then the only other thing that we want to talk about real quick is what happens if our call to malloc fails. And so in this particular case, we just blindly assumed that our malloc would in fact return memory, but if there was an issue in which there wasn't enough memory available, or maybe there was a permissions issue or something along those lines, what would happen? And so to understand this a little better, I encourage you to look at the Wikibooks article that associated with the malloc function, and specifically then what happens after you make a call to the malloc function. If in fact there is an issue, you would result in a null pointer. So the first thing that you would want to do is to verify that there is in fact a valid pointer. And so we could make one slight improvement now in our earlier malloc_01, and that would be that simply after using malloc, but before we attempt to do anything with our array, we simply just check to see if it is in fact not null. And so a good place to put this without disrupting the flow of our code would simply be right after our display. And so in this case, what we'll do here is we'll say if our array is equal to null, then what that means is there was a problem. So printf and error failed to allocate enough memory, or some message similar to that, as well as an else. And then what we can do then is we can simply move all of this additional code inside of the else branch of our if else, because this branch then assumes that the array is not null, and specifically that pointer is in fact not null. Now, normally you would check this immediately after allocating or immediately after making a call to malloc, but in this case our function, we would want to actually see the address that was returned. So since this is sort of a demo here and we are expecting things like this, then these calls right here, because we already handled it in such a way inside of our display int to check that our array was not in fact null, then we're relatively safe. But you would consider immediately making this check after making a call to malloc. So once again, hope you found this video useful. As always, if you have any questions or comments, don't hesitate to ask, and thank you for watching.